Okay, so 10.1, we're going to do operations with matrices. We are going to add, subtract, scalar multiplication. We're going to do all that today. Okay, so a capital letter is used to refer to an entire matrix. So the matrix name is A, or is B, or C, whatever. But it's a capital letter. That's the name of the matrix. A specific element can be referred to by using subscript indicated with the row and the column. This says how many rows? 3. How many columns? 2. So it's row by column, and so it is a 3 by 2 matrix. Okay. They showed over here in row G, column J, so this is A, G, J. Usually they name this like 1, 2, 3, and this 1, 2, so this would be 1, 1. Row 1, column 1. So the next one would be row 1, column 2. And this one down here would be row 2, column 1. And then row 2, column 2. And then row 3, column 1. And row 3, column 2. Okay. So 3, 2 would be what? What element would be 3, 2? Row 3, column 2. What element is in that? Row 3. 1, 2, 3. 8. So A, 3, 2 would be 8. Make sense? Okay. Row by column, name, elements. Elements are things in it. Any other questions? We've dealt with kind of matrices before when we did Gauss-Jordan elimination, right? Okay, so Cool Threads clothing store uses matrix C to represent the prices of women's clothing. There's the matrix. The columns represent the brand, vintage, casual, and distressed. So vintage, casual, and distressed. And the rows represent jeans and jackets. So jeans and jackets. Do you guys use matrices to find things in other places? They're not. Yes, you do.
I don't know.
In science, all the time you have a table, yes? A table is a matrix. Okay? If the sales tax is 5%, how can you use the matrix operations to find the amount of sales tax for each of these? So if I want the 5%, and I want just the sales tax, how do I find sales tax of an item? Cooper, that's a no-go. Shut your computer. If sales tax is 10% of whatever, how do you find how much tax you're going to have to pay? What math do you do? Multiplication, yes? So I'm going to multiply everything in here by 5%, which is 0.05 of matrix C. Okay, so that tells me to multiply everything in matrix C by what? 0.05. So it's going to be 320 times 0.05, and then 210 times 0.05, and 160 times 0.05, and 240 times 0.05. It's not a negative. And 110 times what? 0.05. Do you see how I'm leaving spaces between the elements so you can clearly see? And then 65 times 0.05. Oops. See that? Okay. Now, if you take out your calculator, you all have that matrix written down? Okay. Because I'm going to have to get off of here and Okay, do you see on a button on your calculator that might help you?
Table, wait, no. It's a table set.
Well, we're dealing with what?
Matrix.
Matrices.
Oh, it does say matrix right there.
So you probably should hit the matrix button, yes?
Mm-hmm.
Which is second x inverse, right? Okay, so you shove this. Got that? Okay, so we don't have anything in, I don't have anything 1 through 9. If I did, I'd have some dimensions over here. So you go to edit. Alice, can you take your bag off the table, please? Thank you. Okay, go to edit and hit enter. What size is the matrix that we just had?
1 by 1. Oh, 3 by 2.
No.
2 by 3.
2 by 3. Rows, columns, right? So 2, and then enter, and then 3, enter. And did it put it up there, what you wanted?
Yeah.
Okay, if it's not right, you can go back up. Like Olive said 3 by 2. So she'd get that and she'd say, oh, wait, that's not right. Right? So you can just arrow back up and change it, okay? So we were 2 by 3. Okay. Put your numbers in before we put the 0.05. Second matrix edit. So 320. 320. And then 210. And 160. You guys have it written down, so tell me if I'm doing it wrong. Before we do anything else, you want to make sure you check and put everything in there correctly. Okay? The reason for that is if you put a negative when it wasn't a negative, or like I put 320 and for some reason only the 3 and the 0 went in, it's going to mess it up, isn't it? Mm-hmm. Okay, does everyone have their matrix in? Mm-hmm. Alex, you caught up?
Almost.
If you hit enter, it moves you through the matrix, correct?
Mm-hmm.
Okay.
I'm good.
Okay, so we had the scalar, when we wrote the scalar, we wrote 0.05 matrix C. Yes? And we just put matrix C in there. So we're going to do 0.05, but we did put this in A. We didn't put it in C, didn't we? Mm-hmm. Okay, so we're going to say 0.05 matrix A. So you have to, on matrices, it's really kind of different than other things. You have to quit the program. Okay, so you guys see the quit button? Okay, so hit second quit, and it'll go back here. And we want it to do 0.05. And multiplication, when it's a variable, we don't have to put any sign in between there, do we? No. You could, but you don't have to. And then go grab your matrix, so second matrix. And then you're just going to hit enter on number 1, or just type 1, either one, it doesn't matter. And does it say 0.05 matrix A on your calculator? Yes. And then hit enter.
Oh,
so that is your sales tax. So the sales tax on $320 is what? 16.
It doesn't let me see all of them.
You have it on your calculator. Then arrow over. Emma, your calculator, not mine. Your calculator should have these numbers.
It does.
So quit looking up here.
Do I write them down?
Yeah, write them off your calculator.
Okay, I was.
Okay, you kept looking up here, so I was like, yours should say.
I was checking if we had the same ones.
Oh, we better have the same ones, right? Okay, so our 0.05 C was 16, 12, 10.5, 5.5, 8, and 3.25. So what does 3.25 tell me? I know exactly what it means. What is 3.25?
$3.25.
What's that mean to me? Cole, what are you thinking? What do we know about this position? What is it?
It's
$1, like in money.
No, but what do we know about that information in that position right here of that matrix?
the sales tax of 65.
What's 65?
The regular price.
The denim jackets. The sales tax on a denim jacket. Yes. Isn't that how you read a table? Yes. So the sales tax on a $65 denim jacket is what? $3.25. So what is 10.5? That's a distressed jacket.
Casual.
Casual what? Casual jeans that cost $210. The sales tax is $10.50. So do these things come over here also? Yes. We got vintage, casual, and distressed. So what is the tax on a vintage jacket? 12 what? Rupees? Rupees? Okay, $12.
What did you just?
Rupees?
What?
Okay, so this is called scalar multiplication because did we scale the whole thing? Yes. What if I ask you for a matrix with the total cost? How would you do that? This is the tax, yes. And this is the cost before tax, right?
Wouldn't you just add them up?
You would just add them, wouldn't you? Yeah.
I already did that.
So it would be 336, right? And then what? Down here? The vintage jackets would be
52.
252. The casual jeans,
220.5.
$220.50. Let's talk money. Casual jacket
$15.50.
and 50 cents. So you're just adding them, yes? And when we're adding, we add element to element. So to add or subtract, yep, I got ahead of my hand. Matrices have to be the same what? Size? Did I say size? Important. So if I have a 2 by 3, it has to add to a what? 2 by 3. Can it add to a 3 by 2? No. It has to be exactly the same. Pretty easy, isn't it? Okay, what we just did was scalar multiplication. We multiplied the whole thing. And I don't know, our slide seems kind of pointless because we just did it, yes? Mm-hmm. So if I wanted the tax for it all, I'd multiply the whole thing by 0.06. And I'd get it. This would be the tax, wouldn't it? Now, I have a question for you. What if I wanted the total without adding? Because the total would be this plus this, yes? But without adding, I want to multiply by a scalar. We did this with interest, remember? When it was 20% interest, we've had to add something in front of it. We added a what? 1? Because 1 would be 100%, wouldn't it? So if I just wanted the total right off the bat, could I multiply by 1.06? That would give me my total, wouldn't it? And that would also be the same of taking it and adding it. So remember that you can do that depending on what they want. Got it? Do you guys want to put this in your calculator again to see if you remember how to do it? We'll do this. We'll do the 0.06. See if you can remember how to do it. You guys can just edit right over the matrix you already had in there. You don't have to put it into another one. You can just overwrite your numbers. And make sure you write the right numbers before you move on.
Oh, did you want the tax?
Yeah, I just wanted the tax.
Oh, I didn't.
Well, you can just work backwards and see if you got it. Did you guys do tax or did you do total?
I did tax.
Okay. So, did you get $4.50, $6, $2.40, $3.60, $1.50, and $1.80?
Yeah.
Okay,
Wait, what is it? What'd you?
right here.
That's the tax.
That's just the tax.
Oh,
Did you
I
just?
did the total right away.
Okay. So if you did the total, you got $79.50, $42.40, $26.50, 106, 63.60, 31.80, right?
Yeah.
Okay. So make sure you're answering the question they asked, though. Okay, because this one just wanted the tax. Are we good? Okay. Oh, we're going to do this tomorrow. Okay. So it says M plus N. I touched it. So we need to do M plus N. So on your paper, write M plus N. And we have a 2 by 2 and a 2 by 2. So what am I going to get when I add them? A 2 by 2. If they were not the same dimensions, you would say undefined, yes? Okay, this is non-calculator. I know you guys love your calculators, but this is non-calculator. So what's my first element? What is my 1, 1?
3.
3. And my 2, 1. I like to do my columns first. I'm weird.
-6.
-6. And 1, 2.
0.
How about 10?
Or 10, sorry.
And then 2, 2.
0.2.
And you guys do NM. Oop, not multiply. You don't know how to do that yet. That's tomorrow.
When n plus 1 be the same thing.
Do it. Okay, did you get the same thing?
Yeah.
Okay, matrix addition is commutative. That's it. Commutative means I can do it one way and the other way, right?
Yeah.
Regular numbers multiplication is commutative, correct? Matrix multiplication is not commutative. If it is, then they're inverses of each other. But in general, the rule is it is not, okay? So the only thing that's commutative with matrix operations is addition. Obviously, subtraction is not, and there is no division. And what did I already say? Add and subtract only if they are the same size. Okay, a lot of times you'll have A, B, C, D, and they'll say do all this stuff with them, okay? So it says which matrices can be combined using addition or subtraction? A plus C. So A plus C. What else? C plus D. A plus D. And then all of them the other way, right? Can anything be added or subtracted to B?
No.
No. Why not?
Because they're not the same size.
Because it's a 2 by 3 instead of 3 by 2.
Okay. Which two matrices would give you a zero matrix when added? What do you think a zero matrix is? When it's all zeros. So which two would give you zero matrix when added? A and what?
B.
So A plus D. So let's see. So 0, 0, 0, 0, 0, 0. That's called the additive inverse, yes? Because it undoes it and gives you zeros. So A and D are additive inverses of each other. How does A plus C and C plus A relate? They should be the same, correct? Only because it's what? Yes, but it's addition, right? So addition is commutative. They are the same. Actually, they're equal. Let's use some math words. Okay, what is the additive inverse of B?
-6 to
Wait. Oop.
going down or across.
Okay, you guys do it. Put it on your paper since it's the last thing. The additive inverse of B. Okay, do you have -6, 2, -3, -5, 0, 4?
Yeah.
Okay, so additive inverse means you're going to get what when you're done? 0. You get the 0 matrix. Got it?
Yep.
Okay, I think we're going to go ahead and do that one slide I skipped over earlier because that's all that we would have for notes tomorrow then.
Let's just do it tomorrow then.
No, it's one slide. Okay, so Cool Threads is using matrices to keep track of monthly sales. In matrix A and B, row 1 represents the sales of jeans. Row 2 represents the sales of jackets. Then we have vintage, casual, distressed brands. What is the sale total for the 2 months? How am I going to do that?
Add March and April.
So we're going to do A plus B. So do A plus B. I would highly suggest when you're doing your homework to write the matrices on your paper because of the fact that if you're looking back and forth between the books, what are the odds you're going to go to the same problem every time? Not very good, huh? Cooper, why aren't you doing this with us?
I'm not getting anything out of it.
Brandon, what'd you get when you did A plus B?
I haven't figured it out yet.
Okay. I'll wait. Tell me, quit doing your homework and do this. If you have A done, go to B. Austin, what are you doing with your calculator? You're supposed to be doing these by hand. The only thing we did with our calculator was like sales tax. Okay, Brandon, you got A done? Cool, you got A done? I mean, the part.
I think so.
Okay, what do you got?
I may have got this wrong.
What do you got?
Don't you add them together?
Yeah.
Okay, then I got 22.
How about 32?
Oh,
Gotta carry your 1.
you're right. 18.
28.
No, 28.
28.
53.
Yes, you did right there.
26.
Uh-huh.
24 and 8.
I got 31. Where? Instead of 24.
No, it should be 24
I don't know how I got 31.
and 80. Okay, you just added them, yes? So what does this say? The difference.
Subtraction.
You're going to have A minus B, yes?
Yeah.
So when you do that, I'm going to show you. You're going to have 14, 10, 11, 15, 28, 35, minus 18, 16, 17, 9, 25, and 45. So what are you going to do to each of these numbers? Subtract.
Subtract them.
So 14 minus 18. You're distributing this negative. That's what you're doing. And what I will usually do, especially if like there's some negative numbers in there, I'll probably like distribute it before I do it and then just combine them. So what is 14 minus 18?
Negative 4.
-4. Okay. 10 minus 16. 11 minus 17.
Negative 6.
15 minus 9.
6.
28 minus 25.
3.
35 minus 45.
Negative 10.
Okay, so what does that tell you?
Well, the negatives mean it went down.
But did they go down?
No. So it went up? Wait. Pause.
What'd we do? Which one is this one? March?
Mm-hmm.
And this is
April.
April. So if we were finding the difference between 2 months, should we have taken April minus March?
Yeah.
Mm-hmm. I was hoping somebody would say, wait a
I did
second.
both.
Well, I did.
When
I
you
did-
want to change between two things, shouldn't you take the second minus the first?
I did B minus A
Mm-hmm.
when we did it by ourselves,
Okay.
but I didn't know if we could have negatives, so I just erased it.
No, you're fine. Why should we have known to take B minus A? I was waiting for somebody to
Because B
say,
was April and A was
right,
March.
you always take the last month minus the one before it, right? The current month minus the one before. So our sales didn't go down 4, 6, 6, and 10. They went what? Up. So what were the two things that did go down?
3 and 6.
What are those?
I don't know.
Your matrix should label your matrix. Should you have labeled your matrix when you wrote them down?
They were jeans,
Distressed jeans.
Distressed jeans, because these are jeans,
casual jackets.
and casual jackets. Okay, so why would I want to know that?
To see which one is selling more,
All right,
you should stock up on.
stock up or quit carrying, right? If I went from selling 15 to 9, Maybe it's time to think about casual jacket, or sorry, yeah, 15.9. Maybe it's time to think about not having casual jackets. Correct?
Get them out.
But going down by 3, is that very much?
No.
No. How much money did these things cost? You guys have them written down. Was it cheap to carry a casual jacket? How much were they a piece? 110. So that probably cost me like 55, right? At least. Was it cheap to carry distressed jeans? How much were they? 160. Yeah, so the 160, that's kind of high, isn't it? So it's important to know your sales. Yes. So when you do these problems, you need to be labeling them. So when I ask you, what does -4 mean? What does it mean?
Vintage jeans.
Went up by
4.
4. And we should have done April minus March. Because you take the current minus the previous. What did we do best in?
Distressed jacket.
Distressed jacket. But how much are we making on a distressed jacket? Like, how much did they cost people? 65. So that was the cheapest thing I in my store, right? Or on here. So that, yeah, it went up by 10, but I probably made more on this. What was this one? Or this?
Vintage jacket.
Vintage jacket. How much is a vintage jacket?
$3.20.
Yeah, so I made more by selling 6 more vintage jackets than I did by distressed jeans, right? Or distressed jackets. What's this top one?
$2.10.
What?
Girl, the casual jeans are $2.10.
The casual jeans are 210.
Mm-hmm.
Okay, so if the casual jeans are 210, then we still did better with these two, didn't we? Okay. So can matrices be used to do a lot of stuff?
Yes.
Yes, I'm going to tell you they all the time. All the time. Okay, so today what you have are these mixed problems together. So you're going to be applying all that stuff.